Right? It's always a pleasure to speak at Stanford. 25 years ago, Dan's class was one of the first classes I took when I was in grad school at Stanford. I like to say that this is my third and most exciting act in life. I'm an AI research lead at Snowflake, working on various things around agents, their evaluation, optimization, and security. And after grad school here, I was on the faculty at CMU for 15 years, and then did a startup called Truera, which was in the AI evaluation observability space. Snowflake acquired us after 5 years or so, like 2 years ago. So today, I want to talk about how we are going about securing coding agents for data tasks. And to be honest, it'll have more problems than solutions. So very much looking forward to the conversation after the talk and collaborations as well. So coding agents are getting very, very widely adopted. It has completely changed how developers go about building software. Things like Cursor and Cloud Code and Codex are the cornerstone of how software engineering is happening. But when it comes to performing data tasks like data analysis, data engineering, and so on, there are a couple of other challenges that we need to get a handle on to really nail those problems. One is that for more conventional software engineering tasks, the context often stops at the repo, whereas we need much more data awareness from our coding agents when they're engaging in data tasks. So awareness of the data catalog, of the warehouse, of the data schemas, and so on. The second area, which is like the center of what we are interested in this conference, is oftentimes we see data leaving secure environments where generic tools will send data to third-party services, and that creates holes from a security standpoint. So the team at Snowflake built this coding agent that we called Coco. It's an AI coding agent for data teams. And the experience is very similar to Cloud Code. There's a CLI that you can work off of. It's also built into, there's also a UI experience where it sits on Snowsite right next to where data-oriented developer teams usually work. Our security capabilities, our enterprise security is strong. Windsurf I had installed a while ago, and recently they're observing that. OK, so here are the kinds of tasks that Coco is really good at. There's a bunch of different things here. I'm going to focus on data engineering and building data agents, which work on data analysis tasks, and share a couple of benchmarking results that we have on public benchmarks. And then that gives you a bit of the orientation about where this kind of coding agent is different, and then we'll dive into the security elements, which is the heart of the talk. In terms of research directions that I personally drive, a lot of the work is around evaluation, optimization, and security. So this is a benchmarking we did on data engineering tasks on this benchmark called AidBench, which was released by dbt Labs late last year. It has 43 total tasks, and these tasks involve building data engineering pipelines, dbt pipelines, to do various kinds of data transformation tasks, as well as debugging and fixing pipelines that have some issues. When we did the benchmarking for this and compared it to Cloud Code, in terms of the headline numbers, they're pretty close. 58 versus 65% might seem like a 7% difference, but the N is small. It's only 43 tasks, so it's just a difference of 2 or 3 in the score. So at this level, I think of these as very comparable. What was interesting is the efficiency of the process. So in terms of the number of tool calls that Coco did relative to Cloud Code, it was about half. The average number of steps that the agent needed to complete the task was also about half, 20 versus 40. And the number of operations, like file reads and bash commands, they were 2x to 4x fewer. And the reason for it is Cocoa has been built with data-specific tools, data which help with data tasks, in particular things like the ability to execute SQL, the ability to create some abstractions of dbt pipelines, and those tasks, those kinds of tools really help the agent go about the task in a different way. Instead of doing, you have all seen working with Cloud Code, there's a huge number of greps and file reads that happen as it builds up its internal understanding of the code base. But many of those steps can be hugely compressed if the agent can go about acquiring the relevant context by executing SQL, for example. And that is a big reason for the efficiency improvements. The other benchmark, this is for constructing and optimizing data agents. A data agent you can think of as one that will answer data analysis-related multi-step questions by going from text to SQL, going across structured and unstructured data. And here, the benchmark that we worked with is DABStep. This is a benchmark from Hugging Face. It has about 375 or so hard tasks. And on those tasks, the first version of the agent that Cocoa created had about 35% task completion rate. So it was able to answer 35% of these questions accurately. But then when we went with the version that was optimized, where the harness for the data agent was optimized, the accuracy or task completion went up to 87%. So that was a pretty significant improvement. And for this, under the hood, we built an evolutionary optimization technique that we called Cocoa Evolve. There's a blog about it, so if you Google for it or ChatGPT for it, you'll find it. Cocoa Evolve is very much in the spirit of evolutionary techniques like OpenEvolve, AlphaEvolve, and others that you have seen. Perhaps some of you may have seen. The difference is that in these evolutionary optimization techniques, there is usually an outer evolutionary loop that searches for different mutants of programs that would do well with respect to some optimization objective. In our case, the optimization objective is to do well on this benchmark or a part of the benchmark, which is the dev set. The inner loop, though, usually makes use of just LLM calls. And that inner loop we replaced with a call to a coding agent instead of just a simple LLM call. And then that gives a lot more power to the evolutionary optimization because the coding agent can do more interactive analysis, it can check its task, it can work much more natively with code bases. And that's one of the reasons that we saw this big lift relative to using something like OpenEvolve. So with that orientation, let me now turn towards agent security. As we engage with customers and users of this kind of product, it's been very interesting to see the evolution of the trend. At the very beginning, the biggest questions were about quality. Does this agent actually do well on the task that we want it to do well on, like data engineering or data analysis? Quality questions still remain central, but the two other questions that have become top of mind now, for large enterprises, like think of the major top 10 banks, the Snowflake customer base has pretty much all of them. The number one question is, what are you doing to secure these agents? These are universal Turing machines that can go in and cause a lot of damage, exfiltrate data, do rogue actions that compromise data integrity. And then for people who are past that hurdle, who are convinced that the security guardrails are in place, and they've started deploying, the question that has now become top of mind is cost. The initial push was to get developers to adopt AI. That has succeeded a little too well. Now the token burn rate in many major companies are 2x, 3x of their budgeted amounts. So quality, security, and cost. I'm going to focus on security today, but catch me over coffee. Would love to chat more about the other problems as well. So there's been a lot of talks about different kinds of attacks on coding agents, including the kinds of prompt injection attacks through bash commands that result in escalation. So this is a screenshot from an attack on Claude from several months ago. Many of you may have seen it. This is obviously fixed now. But the idea behind this attack remains very central, where if you think about how Claude Code works, and Cocoa works in a similar way, there is a directory, working directory, and within that directory, all the activity of Claude Code should happen. It should not be able to jump out of it to go one level up in the directory hierarchy and then go to some subdirectories outside of this safe zone, if you will. And if you just ask, or if the adversary asks through some prompt injection to make such a change to a different directory, even Claude in itself will detect it and will block it. And instead, this attack is doing something a little more convoluted, a little more devious, where the effect of this is pretty much the same, where it goes up one level in the directory hierarchy and then goes into a subdirectory called restricted, where Claude Code should not be able to get to. But it does, because if you're just looking for, if you have a list of safe commands and then you're just checking if those appear, then things like listing and echo are all safe commands, but this composition makes it go to this kind of privilege escalation. This is the other kind of attack that we worry about, which is now with coding agents getting broad access, if the coding agent has exactly the same privileges as the user on behalf of whom the agent is acting, then it can do a lot of damage. So you want it to be much more contained. In this example, there was, when OpenClaw came out, I remember there was a story about an engineer who was playing around with it and gave OpenClaw access to their credentials and asked OpenClaw to go out there and make them some money. And 6 hours later, they had $280,000 in their bank account. But what OpenClaw had done was that it went and created a whole bunch of credit cards and then took cash out of those credit card accounts and put it in the account. It met the user specification. A month later, her credit score tanked. So we don't want these kinds of scenarios. We want agents to be much more contained. We want them to have separate identities and also privileges that can be much more tightly scoped. So these are somewhat related but distinct kinds of attacks. And in the context of Cortex Code, this can be quite one kind of example that is very related that I want you to think about is if some attack like this happens, then that can result in this kind of sandbox escape. The attack would have come in, let's say, through a call to an external MCP server, which got processed, and then Cocoa escapes the sandbox, the working directory that it should work within. So in terms of how we are going about securing Cocoa, these are 5 of the key pillars that we have been building out capabilities around: red teaming and adversarial testing, policy guardrails, agent identity, and these three are very tightly coupled, sandboxing, and careful observability. So let me touch on a few principles here that we are finding to be effective in this context. So one kind of principle, and this is an area where Matt Fredrickson, Zico Coulter at CMU have done a lot of interesting work, and we are also partnering with them and their startup called Grace One AI. Shahan is here somewhere. Maybe he was here yesterday, gave a talk at the last session. So the key idea here, which we have found to be quite effective, is this kind of circle where you start with a red teaming arena where human experts come in, they participate in various competitions. And through that process, you collect a large set of adversarial examples of adversarial prompts. In their case, they now have 8 million examples. And then that data set can be used to train agents that can adversarially test your agents. So in our case, it's Coco. So yesterday, we heard a talk from Anthropic, which was highlighting that adaptive attacks were hard. That paper was from October of last year. So since then, there has been a lot of work on developing agents that can adversarially test in an adaptive way, that can move second and adversarially test in a second way through second moves other agents like Coco. So we are finding that this combination of using capabilities like this to be very effective in proactively seeing where adversarial attacks that can result in data exfiltration or rogue actions exist in the attack surface of coding agents. And then that testing produces a whole bunch of data, which can then be used to post-train open source models to really make them robust guardrails that can detect and block these kinds of indirect prompt injection attacks. So that, and then you can put these, you can continue this loop by putting the secured agent again back into the arena for additional human exploits. So on this first topic, I think I'll leave it at this in the interest of time and say that what we are finding is two things. We have a function internally for red teaming, which includes human experts who are personally, aggressively red teaming our agents, but they're also using products and tools which have agent-based adversarial testing to really scale up. And we are finding interesting examples of data exfiltration and rogue action kind of attacks, which are then giving us the data we need to post-train our policy guardrails. On the policy guardrails, I'll mention a few things here. At the input level, there's a lot of focus on catching injection attempts before they even reach the LLM. And here, what we are finding are these kinds of stochastic guardrails, which are LLM-driven. Think of these as models like Qwen being post-trained on these very large adversarial feeds, which are millions of examples, but also further post-trained on internal examples, which carry the context of your own enterprise, which is missing from public data sets. And these, the post-training is not done once. It's done on a regular cadence, on a weekly or monthly cadence, depending on how much data you're accumulating, so that as the adversarial attacks evolve, you are getting the post-trained model to react to that as well. We are observing quite high precision. The false positive rates, I would say, it varies a little bit, but it's between 0.1 and 0.2%, which is acceptable for our settings. And then the true positive rate, the way we are checking that is through having an internal eval set, which has a collection of known adversarial attacks. We are also getting data from other sources. And there also the coverage has been really good. On the output side, there are a number of interesting directions that we are working on right now, which don't just make use of stochastic guardrails, but also more deterministic guardrails, so enforcing access control and information flow control policies on agents, guarding agent skills, and so on. Where these false positives arise is an interesting spectrum of areas, which also gives us new directions to push this further on. For example, one area where we see false positives arise are when if you're trying to run these guardrails around skills. Because one of the things the guardrails that these models learn is, it's a bit like my 11-year-old daughter. If I'm overly prescriptive and I tell her to do this or that, she will always object and block block that action from happening. Many of these adversarial prompts have those kinds of very specific directives, like ignore instructions, or do this, or do that. And one kind of general concept sometimes these guardrails learn is that if I see a piece of text that's overly directive, that's telling me to do this, and then this other thing, that's likely an adversarial prompt. But a skill is very much that. A skill is a workflow. It is intended to be prescriptive. So there's opportunities here to do something perhaps a little bit like what we saw in the open AI talk, where there's a hierarchy of instructions, and during the training or post-training process, you tell the model, get the model to learn that in the context of skills, this is OK, but in the context of a tool call result from an untrusted source, maybe it's not. There's a lot of richness on this slide that we can pick up in the coffee break. Agent identity is another very interesting area. So there, I'll leave you with two thoughts, and we are seeing some examples of this. One is we do want agents to have their own identities with their associated rights. So there's a long-lived identity for agents that will go beyond a single session. And then the other is we want agents to be acting sometimes on behalf of users. So if an agent is acting on behalf of a user, then it acts with the intersection of the agent's rights and the user's rights. But that's just one paradigm. The other paradigm is because the agent has its own persistent identity, you can constrain it in different ways in different settings. So you may have seen the release of Claude Tag, for example, which came out a few days ago. In that context, an agent is not acting on behalf of a single user. It's a multi-user setting. It's more constrained by the context of the channel rather than by the user. So having this independent identity lets us do this. A lot of this we have done internally in our own enterprise setting, but for this to work in a cross-organizational manner, of course, we need standards. There are several efforts. There's a proposal from Okta, the Agentic AI Foundation that Snowflake is a part of, and Anthropic, many of the leading companies, is working on some of these standards. So these will likely firm up in the next quarter or two. The one other kind of defense in this context is sandboxing, especially on the client side. We also have server-side sandboxes. But when we think about the sandboxing, the main kind of insights here are that you want to invoke tool calls from within the sandbox. And at the same time, for coding agents to be useful, you cannot constrain their effects to be just inside of that sandbox, right? So even if we say that Claude Code or Coco will work in this working directory, sometimes we want it to have effects outside of the working directory. It might be editing or updating a database schema, which is on Snowflake, or it might be doing some web fetch where it's going out and getting data, reading docs that are on the web. So that's where kind of the hardness of the problem is, because now all of these actions which can have effects outside of the sandbox need to be controlled, and you need kind of guardrails there. And that's another area where we have ongoing efforts. And then finally, for observability, despite our best efforts, there will be new kinds of issues which emerge in practice. So having really robust server-side logging, real-time anomaly detection, audit trails, these are hugely important. So with that, let me wrap up with the final takeaway that these are the 5 of the key pillars that we are finding to be extremely important to secure our coding agents for data tasks. Agent identity and policies is is another extremely important area that I'll be happy to talk about more. And let me open it up for questions. Thank you very much.
Thank you very much. So you mentioned training with a lot of adversarial data. So what source did you use for that adversarial data? And how are you sure it actually represents the reality? Because likely the latent space of attack is likely pretty much infinite. So how are you avoiding basically over-focusing on attack you know rather than all the attack you don't know?
Yeah. That's a very good question. I mean, the sources are, I can only answer your question at a high level. So, right, I cannot name my sources because that's very, you're at Google, right? What are your sources? Would love to learn that too. Let's talk over coffee. But you're getting at a very important principled question, which is, how do you make sure that the data is representative? And there are two things we're doing for that. One is getting broad coverage from data sources that are publicly available or vendors that are sourcing data through arenas, through their own internal teams. So having diversity in the sources through which that data can come in is extremely important. So that's one. The other source of data is internally we are doing, for customer data, we can't do that. But for our own data, which is like our teams are heavily using the same coding agent. And through that process, there's a rich data set as well. And that data is also being examined, analyzed, leveraged for this purpose. I mean, I think this is where the state of practice is. Would love to chat more and see. But I think we had lots and lots of talks here about prompt injection attacks, right? And we have made some progress. And this is one point, I think, in the space where there is evidence of success. But there is a lot of open, someone tomorrow might come up with a better idea that really nails the problem. I don't think we're there yet. Yeah.
Yeah, I think that's a great talk. So with respect to agent identity, right? So how do you see agent identity when, let's say, there is a COCO data agent and it is spawning another agent, and now the principal is not the user because this data agent is not acting on behalf of the user. Like that, you could have multiple chains, right? So have you looked into SPIFFE or Spire when it comes to agentic identity? Let's say I have a COCO data agent running within a Kubernetes cluster. Now, as you rightly pointed out, the scope might be local. Now, this data agent might spawn another data agent running in a different Kubernetes cluster. So there has to be a new kind of policy that has to be applied. Any thoughts on that?
Yeah, very good question. In fact, the Agentic AI Foundation working group, that is, if you're at Google?
I'm there, yeah. Herman Erico, yeah.
Okay, great. So that's where we need to go. I think right now we have a solution. The framework we are thinking of is, for internal work, is we have, much like users have identities, agents have identities, and then you can have like a lattice where agents can have sub-agents with identities and so on. But to do it in a way that cuts across organizational boundaries, that's exactly the direction that the
Any thoughts around relationship-based access control, wherein you can have the attributes between these data agents, like COCO data agent 1 spawning COCO data agent 2, and how you can use these relationship attributes between these data agents to create a policy and apply that as a part of the identity?
Yeah, we are actively working on that problem. I think there were some discussions yesterday also about this, but user intent-based dynamic access control in a more task-scoped fashion is where we are headed, right, as a community. No one has quite nailed it yet, but it's hard for a few reasons, right? One is that when we were trying to, agents are very dynamic. So what do you anchor it on? Are you anchoring it on this agent's plan, or do you create another agent to do the plan to see what kinds of access it needs? Those are things that are being figured out right now, but that's exactly the direction we are headed and the broader community as well.
Thank you.
Thank you. I just want to pick back on what he just mentioned on agent identity, because that's a big problem, at least that I've been looking at. You mentioned that we have agents that are now acting on their own identities and also on behalf of users. Without telling us about your company, how is that possible? You mentioned that now agents have their own identities. Are those service accounts? Are those AD or non-AD? Is there like a HashiCorp vault setup that's independent of the enterprise? Without divulging your secrets, how is that possible?
Yeah, I mean, service accounts is exactly one way to do it, right? So having an agent identity associated through a service account principle. So that's one thing that I can tell you we are doing. Yeah. It is divulging a little bit perhaps, but you're right. That's one way, because that gives it a persistent identity. But there's also setups where the agent does not need a persistent identity, right? So let's say that a user has spawned off a task, and within that there is a small task that the agent has to do within that session, and in fact we don't want any of that state to be retained for security reasons or data protection reasons. Then it's also possible for there to be an ephemeral identity, which is restricted in scope to just that session. And then that's like the user with some additional tag is the temporary identity, like the ephemeral identity of the agent, and then it runs, and then it's gone.
It sounds good. Yeah, we have noticed that most of the time, because engineers, they just want to do their job, while we are trying to enforce like service accounts or these privileged account, people still use their individual accounts in AD, and the same permissions have been propagating in the enterprise. And you mentioned about visibility and being able to track.
Yeah.
I don't know if we are there yet, but being able to like attribute an individual from an agent or a person violating company policy using their own username and password to give to an agent, that will also be kind of like an interesting section.
Yeah.
One of your sections you also mentioned, you said OMCP and other tools are running a sandbox. Yesterday, and I think the day before, we also heard from people who were running different sandbox environments. Some were running like individual Docker containers per MCP, individual Docker containers for anything really in AI environments. How are you running that? Was from the slide, it looked like the sandbox is one item, and I'm curious if that's something that
I mean, successful. At a high level, you can think of this as kind of an isolated full VM, which runs in a containerized way on the client's machine, right, for the CLI experience. There's also a server-side sandbox we have, but the client side is like that. It feels like if we let you go, you'll go for the next 30 minutes. We should let the next speaker on, but thank you very much.
Thank you.
We'd love to continue over the break.